So I'm Frederic Maire. I'm a senior lecturer in the School of Electrical Engineering and Robotics and part of the Queensland Centre of Robotics too. And I'm doing research in artificial intelligence, machine learning and a bit of robotics. For the last few years, my main research focus was on environment monitoring, in particular detecting marine animals from aerial images, so images collected with drones. And we develop a technique based on deep learning to recognize, so to detect different species like whales, dugong, sharks, turtle. This project has matured and now the technology is quite common, quite widespread. I'm also working with a PhD student who just graduated, so we have been working with this PhD student, Olga, on animal re-identification. So the re-identification problem is different from the detection problem. Detection, you want to say, oh, there is a whale here. And in re-identification, you want to say, oh, this is the whale that we saw 6 months ago, and we gave it this identification number. So we have been focusing on Manta array for the re-identification problem. So in Manta array are challenging because compared to the problem of re-identification of people, so when you take picture of people, so it's generally in a controlled environment. Whereas if you try to re-identify Manta array, the environment is more challenging, so it's underwater. So lighting conditions are difficult, so the visibility, there might be turbidity in the water, and also the angle of view might be quite varied. So generally when we try to re-identify people, so we have frontal image of the people, whereas for Manta array we use spot pattern in the underbelly. The belly pattern, the spot pattern are almost like a fingerprint, so they are quite individual, like a spot for land animal like leopard. So they are quite specific to individual. So this is what we relied on. We were able to train neural network to do this. And once we did this, we say, okay, so we can now look at the problem of re-identifying Manta arrays.